Let's now speak about the last advanced programming technique that we will see in this session, which we will call, well, we and everyone calls lambda functions. Lambda functions are functions that don't usually have a name and that are used in very, very specific contexts. And we will see some of those contexts and why they matter. Lambda functions can be defined using the lambda keyword. So for example, I can just write here lambda x comma y semicolon, and I get x times y. Okay, and when I do that, I get an answer from Python saying, hey, you have created a function called lambda here. Well, not called lambda, you have created a lambda function here. I can call that function by using parentheses. So, and then giving it a list of attributes. So if I give it 5 and 11 arguments in this case, Python automatically takes them and puts them here in the list of parameters of this function, and then that's what the function did, and it has just multiplied 5 times 11. So this does work as a function, and I can give it arguments for its parameters. I could even give it a name. I said they are nameless functions, but I could give it a name if I wanted to. I can say prod is this thing, and then I just, instead of writing the thing again, I just write prod and give it the list of arguments, and I get the same result. So lambda functions are, first of all, and as we have seen here, functions. So they have their body, they have their parameters, they work just as regular functions. But they are not normally used as regular functions. Instead, they are used in context where we need some very quick and dirty function that we will use there and nowhere else. So we don't need to bother defining with a def word a function somewhere so we can reuse it whenever convenient. We don't want to reuse those. They are just very simple. We just want to define them here very quickly and be done with them. This is the goal of lambda functions. So suppose I want to do something very simple like subtract 1 from all the elements in my list, in one list that I have. Okay, I'm going to define this my list as the list of the iterator returned by range of 10. So range of 10, as you know, goes from 0 to 9, and I'm putting this in a list constructor, so I get this very list, 0 to 9, different elements in a list. Okay, this is the output of this print function. And then I want to do something to all the elements in this list. I particularly want to apply -1 to each element. So first I'm going to define a lambda function that does this -1 thing. It receives something and does that something -1. And then I'm going to use a very powerful function in Python called map. And map does exactly this. It applies the same function to all the elements on an iterable. Okay, map takes a function, which in this case I'm using a lambda function for, and applies the function that I have given it to all the elements in one interval in my list. So in this case, it takes all the elements in my list and applies this x-1 function. And I get this new list of R, and I get -1, 0, 1, 2, 3, 4. So I have applied -1 to all the elements in my list. Map, by the way, is a very powerful tool of something called functional programming. And I'm not going to stop to speak a lot about functional programming, but maybe we will do it in some later unit, because it's very, very powerful. With map, you can, as I said, apply the same function to all the elements in one iterable, for example, in one list. I could also do, instead of map, and using lambda functions too, I could use filter. And filter does something similar. Filter receives a Boolean function and an iterable and returns all the elements of the iterable that return true for the Boolean function. Okay, map received one function and applied it to all the elements in one iterable. Filter receives a function, but it has to be a Boolean function. It has to return either true or false, and it only returns the elements that evaluate to true in my function. It's very convenient to filter things, as its name indicates. So for example, if I have this masse tuple in this case with different elements, 10, -6, some strings here, some float values here, a list, a non-value, dictionary pair, okay, a dictionary with one pair to be fully precise, then I can define this lambda function, and that's why we are doing it here. Filter, the same as map, is very commonly used with lambda functions, and I will just return x if the type of x is either float or int. And because we want to return numerical elements over 5, okay, so I also have these conditions. So if I run it with this previous list, I only get the elements that are numerical and over 5. So for these functions that use functional programming like map and filter, and I really encourage you to give those a look if you're interested, and if not, we will do it some other time. They are very commonly used with lambda functions, these very quick and dirty functions that I can define without even having to give them a name. Perhaps the most common use of lambda functions, though, is in combination with sort or sorted Python built-in functions. Okay, so let's suppose I have defined, using a list comprehension, a list of tuples, and in each position I have a number from 0 to n-1 to 14 in this case, for example. And then I also have, in the second element of the tuple, user plus the string change of a random number between 0 and 100. Okay, so I have a list containing tuples. Let's run this. List containing tuples from 0 to 14 and a list containing 14 tuples, and in each position, in each tuple I have the first position that contains an integer number corresponding to its position actually in the list, and a second element of the tuple that contains this user plus a number between 0 and 100. Okay, so I might want to sort this, but this is a list of tuples, so sorting tuples is not straightforward, it's not automatically defined. So I can use lambda functions to define how I will sort. This is very common. There is even a key parameter in the sorted function of Python that already accounts for that, so I can tell it key, the function that you will use to sort is this lambda function, and then define whatever I want it to do. So for example, whenever you get an element here, you have to take the tuple that you have at each list position, consider element 1, so this one, and only consider the elements from position 4, so 0, 1, 2, 3, 4, so only the number, ignore the user part. Here I'm using list slicing. string slicing to be super precise, and then turn this into an integer. So basically I'm capturing these numbers that I have randomly generated and turn into string, and I'm turning them back to integers, and I'm sorting my list corresponding to them, and I'm getting that. So first element is user 0, even though that was in position 10, user 9, user 11, user 19, 20, 24, 43, and so on and so forth. So once again, as I did with map and filter, with sorted, which is not functional programming, but is a very, very frequently used Python built-in function to sort things, I can define how to sort using a lambda function. Okay, so that's it for lambda functions. Functions that I use probably just once in my code in very specific contexts, map, filter, or sorted or something similar, and I don't even bother giving them a name because they do something simple. Okay, I could of course use map or filter or sorted with more elaborate functions that I defined in the usual way. That would be no problem. But if I want to do simple things, lambdas are convenient, are more compact, and are often also faster. Okay, that's it for lambda functions.